Okay, so I want to start this lesson with a problem that is not on your notes, and you don't have to write this part down if you don't want to. But I want you to see that if I asked you to do the derivative of this top function right here, and you were doing it with respect to x, dy dx, excuse me, then you would just end up getting 9x squared plus 14x plus 15. And hopefully that feels comfortable, and you've done that like literally hundreds of times. But if I asked you to do the derivative of it, and it's the exact same function, but with respect to t, okay? Now, again, notice there's not a t anywhere in sight. Doesn't mean I can't do this derivative. All it means is I'm going to do the derivative the way I thought I was going to, 9x squared, but now I have to just sort of make sure that I have a little notation here that says, hey, I did the derivative with respect to t. All right, and then over here, I would still have the 14x like I did up above, but just so to remind everybody, hey, I did the derivative with respect to t. And then on the last term, I'd still have the 15, but I did the derivative of that x with respect to t. Okay, so it's just a little bit of added notation. All right, so now when I go to do these problems, and notice it says that I'm doing these derivatives with respect to t, I'm going to have to add in notation on every single one of them that I am doing these derivatives with respect to t. Okay, so let's start with number one. So the derivative of p with respect to t, and the derivative of this side is just the 4, but it's the derivative of x with respect to t. Okay, so again, I don't think there's a single problem on here that has a t. So here, if I'm doing the derivative of a, but it's with respect to t, and then this is going to be the product rule. The first times the derivative of the second plus the second times the derivative of the first. All right, notice these are all derivatives with respect to t. Okay, so for number 3, over here on the left, the derivative of a with respect to t. Here, I'm going to bring this 1/2 down, and I'm going to do the derivative of this as a product rule. The first times the derivative of the second plus the second times the derivative of the first. Again, all with respect to t. Okay, let's try number 4. Derivative of c with respect to t. Over here, the 2 pi, that's a constant, just bringing that down. And then the derivative of that r is being done with respect to t. Okay, over here, derivative of a with respect to t. And then the pi just comes down. Pi is a constant. I'm not taking the derivative of it. The derivative of this is 2r. Just a reminder, we did that with respect to t. All right here, I'm going to have the derivative of v with respect to t. And then this is 3x squared, but it's the derivative of x with respect to t. Okay. You may want to just try the rest of these sort of on your own, and then check with my answers, which are right here. All right, turn in the page. Here we go. All right. Again, these are all very, very similar, just a lot of practice. This is a constant. I'm going to bring it down. This is going to be the product rule. All right, over here, f prime of x, negative 10x dx dt. Okay, now number 12 I actually like because there's actually a t in here. All right, so I'm doing the derivative of this side, which is f prime of p. The derivative of t is 1. Now, I suppose I could write dt dt, but that doesn't mean anything. It equals 1, so I'm not going to. All right, so then continuing. Ooh, these have t's in them. I don't need to write the dt dt's on those. So x prime of t is going to be negative 10t plus 30. Ooh, this is a good problem. On 14, you're going to want to make a decision on what's going to be your first and what's going to be your second. So I'm going to put some parentheses in here. This is going to be my first. Okay, so here we go. The derivative of v with respect to t. And now I'm going to do the product rule, but there may also be some chain in there. Here we go. The first times the derivative of the second plus the second, and then the derivative of the first is going to be, it's like your peanut. It's like I have to do the chain. So let's go inside there. It's the first times the derivative of the second plus the second times the derivative of the first. All right, and then down here, trig functions. The derivative of cosine is negative sine d theta dt. And then over here, I'm going to have the quotient rule. So low d high minus high d low, square the bottom, and away we go. All right, and then this last one is asking you to actually do the second derivative. Now, good news is, because of notation, this is already the first derivative. So the second derivative, I'm going to keep that constant out in front. The derivative of this stuff is just negative dw dt. I'm going to clean that up a little bit. So negative 1/4 dw dt. But since the directions say write it in terms of w, I need to make a substitution. Okay, what I mean is since dw dt equals all of this, I'm going to change all of that. So now I'm going to have this. Negative 1/4 times 1/4 times 100 minus w, which would simplify to be negative 1/16 times 100 minus w. All right, that's it.